Hello everyone. I guess we will start in any way. Um, yeah, Tim, do you hear me? I presume not. Well, quite challenging question. All right, anyway, let's try and start our presentation today. Hopefully it will be done smoothly without any questions. We'll try to make it one by one, I guess. So since uh, I presume that the team doesn't hear us, so it will be hard for us to build the dialogue between each other. So anyway, just a new way of doing webinars. That's why we have some harsh beginning of it. Today we perform together with Escort Group. Thank you for joining for a joint webinar of Galileosky as the fleet management trackers providers and Escort Group for fuel management sensors providing. Yes, today we will talk about quite interesting topic, and this topic is about tracking the vehicles and the fuel in the quarries and mines for the industries who are involved into gathering the mineral deposits from the earth's ground. So hope you are safe and sound, everyone. Hope these days not affected you or your family. Probably we will start. Yeah, team today with me. So yeah, and now he hears us. Great. So yeah, we will be able to build the dialogue. So hello everyone once again, Tim.
Yes, hello guys. Tim with Escort Monitoring Systems here.
Okay, awesome. I already made a small introduction, so let me then start our webinar. Um, all right, small agenda. We will talk about GPS monitoring in the mining industry. What challenges are there? What problems the customers from this industry face every day, and how we can solve those problems with the telematics systems. In addition, we will definitely talk about tracking and monitoring outside of GSM coverage. So, because it's quite a crucial problem for the mining industry since they are lacking GSM, obviously. So this is why we'll stress our speech on this specific part. We will also discuss about how did the International Mining Corporation analyze the equipment fuel consumption and facilities and plant performance, and why eventually team I guess will definitely explain how they have why they have chosen Escort fuel level sensors to control fuel consumptions and drains. So small organizational part of our webinar. It will be about 60 minutes long. The webinars are always sent to those who have registered. So once you have left your email address on the link, we will definitely send you the video after the webinar finished. And you can ask any of your questions on the questions tab. So just to double check, it's hidden over there. Mind that it is marked with a question mark. There is also the chat for you to conversate between each other, to talk, to discuss, to share your problems or ideas. And the questions you leave in the questions tab will be tracked one by one, and we will answer me or Tim after we finish our presentation. So let's move on. Let's move on to the start of it. GPS monitoring in the mining industry. What are the tasks there and how can we solve them, and what is the most important for them, how we can get the accurate data which is required in this industry to be delivered in order to be analyzed and in order to be used in the fleet efficient fleet optimization. So, and how they can eventually obviously guarantee the success for mining companies. Um, There are quite widespread difficulties that mining corporations are faced. For example, well, you can imagine the mine, and I believe that some of you have already been to the mine before. If yes, put your plus on the chat, or even if you had some project done in some quarry or mine, uh, write something. How difficult was that? I heard there's not enough of air. I've never been there, but personally, I've really hope to occur someday inside the mine. But it's very essential and it's very obvious that it's a very difficult job to do. There's not much of infrastructure over there, so not telling about the roads, which is also mentioned on the slide. There's even no any communication. I mean, in terms of GSM coverage, at least. So the telematic system and GPS tracking is kind of difficult there. There's no GPS even if it's close mine. And once we don't have the roads, we cannot control. It's a problem to control the transportation of goods from the quarry to the port, for example. So a lot of different difficulties, a lot of different challenges. Still, they have to do their job. Still, they want it to be efficient. They want to earn more money, to save more money with telematic system. And if we can look at the tasks, not the challenges, but the tasks that telematic system might solve in order to bring extra benefit to the mining company, we can we can tell about different type of tasks. So first of all, we can talk about automation of the different stages of production and delivering the minerals from the quarry to the port. Not only tracking it on the map, but also somehow make it automized. So reduce water and fuel consumption. I guess Tim will tell better about fuel than me.
Most definitely. Thank you, Maxim. The fuel is a very expensive commodities nowadays, and especially if you think about mining machinery. You've seen those trucks. Some of them are 2-story high. It's huge engines, huge volume of the engines, incredibly big tanks. Some of the tanks on some of the machinery could be as deep as 3 meters. It's a lot of fuel. We'll get to that later. We have some digits for you guys, and the digits are incredible. I couldn't believe myself when our partners told us how much fuel was stolen, was underfilled. I mean, it's crazy. So yeah, it's very expensive to waste fuel. And as I also been told, never been to the mine before, but water is very crucial thing to use in mines as well. They use it for plenty of things over there, and it's not easy to deliver water to that places. So Maxim, we will talk about this fuel particulars later. What about exclusion of the human presence?
Yeah, just to stress it out, the conditions there are very harsh. So if it's possible, it is better to exclude the human presence out of mind. So yeah, that most definitely that it's impossible to do 100%. So we still need human, at least now in this year, but we can do what we can in order to reduce the number of people there, in order to reduce the time that people spend there. So I believe that you will agree with me that telematic system might help in that, by implementation of remote control, by automatization of some of the stages of production, by doing something else. So and eventually optimization of fleet and stuff. Yeah.
Yeah, when we speak about human presence in places like this, we definitely are we are obligated to minimize human presence. So we cannot exclude operators, machinery operators at all. But when, for example, we get down to the security of the monitoring system parts, such as fuel level sensor, for example, we have to make them as durable as possible. The mining conditions are incredibly harsh. We've seen these fuel level sensors, the photos of them 2 days after the installation. It's not easy to find the fuel level sensor on the machine. So much dust, so much residue is, it's everywhere. The air is very polluted, so everything is covered in dust and pieces of, of these rocks they harvest out from the depth of the earth. Also, we should not exclude the possibility of vandalism, because fuel monitoring system is not something, not all the drivers. There are plenty of good people, but some of them, they do not like the systems implemented, because they take away the money they can earn while stealing the fuel. So we have to make them as strong as possible, virtually unbreakable.
Yeah, and actually the fuel level system is what helps them to optimize their fleet, right? Eventually, and even the staff operation, because yeah, there are, as you mentioned, there are very honest people who will never steal anything, but there are some cases, I believe.
Yeah, I mean, generally we dream about, well, it really is up to the end user, what they do, or how they sanction the drivers. But generally, when we speak about this ethical problem, we offer, at least we recommend people to save money on the fuel monitoring system and then pay this money to hire more professional operators. I guess, it's a win-win situation for all of them. A professional operator is not only, he's careful about safety, he's careful about how he operates machinery, and then if he's paid good enough, he has no need to steal. But that's a bit, out of our reach for now.
Yeah. All right, and as mentioned, it's quite important and crucial for the mining industry. And what telematics system might do that for that is to improve the safety at the fields. So by having the control, by having some processes optimized, by having the human presence reduced, we can improve the safety, and it's very important because, as mentioned, it's a very hard job to do, and we should always think about safety. All right, let's move on. And eventually, we can keep track of everything going on in the field with telematics system. We can track performance of drag lines, dozers, drills, excavators, other equipment that are doing job on that object. We can control the time once the certain object have started its job and once it is completed, and we can check even the time between the different stages in order to optimize something to make it more efficient. We can gather and receive data automatically about how much of mineral deposits we have gathered and how much we have delivered. So in order to track discrepancies and in order to keep it safe again, so economical, I mean. Yeah, we can first of all get information delivered to the platform, and then to check whether it was like we have gathered and like we have delivered. So eventually it's about optimizing the mining workload. It's about monitoring the real fuel consumption, prevention of drains, and you will tell about after my speech in details, and about warning the dispatcher about any critical parameter that occurs or violations if something happens wrong by the driver or someone else. So, but you probably know that there are some significant reasons why different mining companies or working on different fields, gathering different mineral deposits, are choosing Galileosky trackers. And one of them probably is widely known is Easy Logic programming, which helps our partners to create customized scenarios for the device operation, to create some fog computing, and optimize and automate some of the processes within the vehicle or within the mine. There is also definitely the opportunity for remote control and setup. So you should not go into the mine in order to reconfigure the tracker. Well, once it has some internet coverage, or to activate some action for it over it. So it helps us to identify the fleet or driver. So to check what was the performance by each driver or each fleet unit, and to check whether there were or not some violations that have been done by the companies, have been used by the companies as the violation. Also, the mining process is quite a complicated one. In order to track the performance, in order to track the activity of each vehicle unit, we should operate with different soft sensors and the software. So there are different types of information that should be gathered by the tracker and delivered to the platform, and it should be sometimes for different cases used in a different manner. So different reports might be required, different key numbers in key significant values that should be delivered to the user, to the manager, that should be visible. So here we have the absolute openness to the integration with any sensors or the software. And probably one of the most important cases why those companies pick and choose Galileosky trackers is our unique and innovative scenarios for using trackers outside GSM. And I will probably talk about it more thoroughly. Hope that most of you know that. Still, I will stress my speech on this part actually. The question for the mining company is how can we get that accurate data that is being gathered by the tracker delivered if there is no GSM service? So definitely the answer would be, okay, I will save data on the black box, and then someone will go into the mine where it is 60 or 70 degrees, where there are a lot of dusts, and the environment is very harsh, and they will find the tracker somewhere there, connect with the USB there to there, and upload information that absolutely inappropriate for them, because we make some people to go inside the mine when it's not necessary to do. So this is why we would like to perform a few scenarios on how can we use Galileosky Wi-Fi trackers in order to get data delivered without human presence, or at least with human presence, but of those human who are doing the job actually, who still have to be there. So first of all, we will talk about our scenario on uploading data over Wi-Fi through the router connected. So imagine that we have some local Wi-Fi network which is deployed at the fleet base or even inside the mine. So the tracker can connect to that Wi-Fi network and collect all the data which is being stored on the black box during the vehicle operation, or which is being transmitted online real time if the Wi-Fi network is right there. So there are a few. So we can do the first way. So we can collect the data and bring it back and bring it uploaded to the server once we are back to the base. Or we can do it right now if there is the Wi-Fi network already deployed. So not really often it happens that we have this opportunity, unfortunately. So instead of it, we have another plan B for the mining companies, which would be using base block hub device, which acts like the hub for gathering the data from other devices. So we have some vehicles that are doing their job inside the mine. So these vehicles are operating there constantly, 24/7, the whole year, the entire year, without getting away from the mine. Let's imagine the point. Let's imagine the story. So there is some a vehicle that makes its trips back and forth to the mine and outside of it. So it might be the fueling vehicle, it might be some certain dozer that make those trips back and forth, or someone else, someone who brings the people inside the mine eventually. So some vehicle that is equipped with Galileosky base block hub. Once it occurs in the range of the devices which have been working there, it collects data from them automatically. So it means that the data which has been stored during the weeks or months inside of the internal memory of Galileosky tracker is being uploaded to another tracker which is installed on that vehicle that will do its job for some time and get back outside of the mine and deliver the crucial information, the accurate data that is desired by the company owners and the beneficiaries, delivered to the monitoring platform. They can track everything with that. So the device reach in this case for Wi-Fi is about 8 meters long, so we can be as far from the client. We can switch between receive and transmit mode with the EasyLogic technology. The data is collected quite efficiently, quite fastly, quite quickly. In just 3 minutes, we can collect around 15,000 points. So it's around 2 or 3 days of quite harsh operation of the vehicle. And as usual, as we usually mention, that we are able to create the customized functionality for the device. So in case if you have some excessive functionality for base block hub, we can reduce that and eventually save some money for the customer. So yeah, schematically it looks like that. There is some certain vehicle that makes its trips back and forth. There is actually first of all the vehicle that is doing the job. We have the hub, which is installed on some vehicle that moving back and forth. And once it is back to the Wi-Fi network or just GSM coverage, it uploads data about this vehicle to the monitoring platform. Actually, I wanted to stress out, also announce the new enhancement we made in terms of this functionality. We have created, we call it so client to hub chain. So it means that it might be not the last vehicle in the chain. So we can have another hub here, and this vehicle will bring the data to this hub, which will be intermediary between the server and this type of vehicle. So eventually we can distribute that network to different objects and get the data delivered eventually. So, but I guess it's important to talk about the data we can deliver it, and I think that I will pass my word to Tim here.
Thank you very much, Maksim. Is the connection quality good? Can you hear me well?
Good.
Okay.
Good.
Okay. Hello, guys. Tim here. All right. Just to mention before I start, integrator company has an NDA, non-disclosure agreement signed with mining corporation. All I can say to you that it is the biggest mining corporation in Kazakhstan that is involved in extraction of precious and non-ferrous metals and minerals, gold mining in a way. So their goal was to get the transport monitoring system for the entire fleet. I can give you a teaser. I had a conversation this afternoon with them, and there are some updated digits in terms of how much money they are saving now, and the amount is incredible. I will tell you, it's something out of our reach. So can I scroll to the next slide? Yep. If you can do that for me, please.
All right.
Thank you very much. So the customer challenges were obviously, the previous one, doesn't matter. He wanted to create a fuel monitoring system. Yes, this one. Due to the very high volume of fuel used in the machines. As I mentioned before, enormous engine blocks, enormous size of the machines. It's a very big fleet as well, and machines are very, very different. So It's not your regular truck with a rectangular tank, which you can just drill, do the calibration and use it simple. There are a lot of challenges for the installation, and so it was not an easy job to do. The biggest thing they wanted to prevent is a fuel theft. And they wanted also to monitor all this equipment. And a very important thing for them was to receive reports. The integrator company is providing weekly reports to the end user, I guess electronically, and they also do it in a paper way with the stamp. I'm trying. Can we scroll to the next slide, please?
You have your action, you can do it yourself.
For some reason, presentation. Oh yeah, my apologies, I found it. New webinar platform. So choice of equipment. The equipment was not chosen just for the sake of it. There were some reasons behind them. Escort TD-150 fuel level sensor is the most reliable sensor that we make. For the past 3 years, reclamation rate for this particular sensor is 0.36%. So this is a very low percentage, and mostly is due to some components that are manufactured by third party. So in case it happens, we just replace the sensors. And Galileosky GPS devices. We have very deep respect for these devices. They are these guys know what they're doing. These devices are durable. They're not cheap, but they're not supposed to be, because the quality is so good. And for this particular conditions, it couldn't be any regular tracker. It has to be a durable tracker that does the job. So the fuel level sensor was connected by our S485 digital interface, which is needed because, as we mentioned before, the tanks are very big, so we need a lot of reference points. And the integrator's goal was to achieve a high level of accuracy. So when I talked to them, they told me that installation of fuel level sensor and the whole monitoring system to the vehicle could have taken anywhere from 2 to 8 hours. And most of that was tank calibration. So what was happening? The big tanks, even though the tanks were so huge, they still did a 10-liter step calibration. So regardless of the size of the tank, they would have put 10 liters per step. And all this calibration, I mean, you can imagine if tank can fit up to 1 ton of fuel, how many steps of calibration does it take, and how much time does it have? But then again, if it's not the easiest job to to implement such kind of system for such kind of machinery, but it did pay off. So here is the example. We see these huge machines. I'm not even sure what are they called, dozers, forwarders, carrier trucks. They have machines that use charge explosion, charges into the walls. The machines are big, it's huge. And these sensors, they have been installed, as you can see them right here. That's how they look on the outside. They are made of the glass-filled polyamide metal, so you can hit them with a hammer. You can do whatever. They are not going to break. And yes, they are all covered in dust, because that's the reality of this type of operation. So these sensors, they would report to the Galileosky trackers by RS485. And then, as Maksim told us before, by the use of Wi-Fi, Wi-Fi technology, this data has been later transferred to the field monitoring system. One of the things that integrator company told us, that without fuel monitoring, the whole implementation of the whole system would not make any sense, because that's where they saved the most money. They know the vehicles are in the mine, so they know they are there. They're not going anywhere, and they also need to know whether the engine is idling or not, because when the vehicle is standing for 3 hours, the engine has to be off. In order not to burn fuel and in order not to burn oxygen underground. So the installation was done with a lot of cutting and welding and inventing a few things because of the complex shape of the tanks, because of the very thick metal. Certain tanks would have very complex inner structure. So as I mentioned before, you have seen delivery trucks, like the ones on the surface. They have regular shaped tanks, nothing special. So here, a lot of drilling, a lot of welding, a lot of inventing of different, methods. Another thing, as we know, in quarries and mines, a lot of tilting is happening. So the vehicles are not on a flat surface. So to avoid miscalculation and fluctuation of the fuel, they have installed 2 fuel level sensors per tank, one in the front. Well, they are supposed to be installed diagonally. One is in the front to the right and one is in the back to the left, for example. So this way you can sum up the volume, the value coming from the both sensors and divide them by 2. Or in case of the complex shape of the tank, it has to be more complex mathematical calculations, but it easily could be done. What else can I say? The reports. Okay, so we've done all these installations. What does it bring us? I mean, where do we save? The report before and the report after. So the pilot was done with 24 vehicles, various caterpillars, as you can see here on the table. So you can see where the fillings is, what's the type of the fuel, how many liters, the discrepancy, fuel theft liters. So these reports were astonishing because first one, the report before. Actually, it's not before the implementation of the system because there was no data whatsoever, but after the first month of the use of the system. So none of the drivers were warned. Nobody knew what is going on. Nobody knew that the new system is being installed. So they just let it go, for 1 month to get these digits, right? So after 1 month, they came to the, as you can see here on the bottom, you see the average fuel consumption by the vehicles per engine hour. Second, you can see how many liters of diesel were filled in average. Fuel theft, if you can see there on the bottom, the fuel theft. So it's not supposed to be happening. Nobody is supposed to be stealing fuel, right? So the report after, that's after implementation of the pilot for 24 vehicles, after 6 months of work of the system. Just to get ahead, the system is still in place. Currently, they have 580 vehicles equipped with this system. So they have, purchased as many fuel level sensors, as many GPS trackers, and as many installations. They did approximately 40 to 50 installations for the vehicles per year. So each year they added 50, 60, the different digits, but currently they have 580 vehicles on monitoring system. So let's get to the money in pilot, right? After the implementation of pilot for 24 vehicles, as you remember, after the first month of the work of the system, the engine liters per engine hours, it was 68.29 liters per engine hour. After the implementation of the system, it fell down to 46.87. So that is almost a third. And this is an average digit that we see throughout the world after the implementation of the system. In certain countries, like I've been talking to a Romanian guy, and he said almost 80% savings. So that was, exceptional, but I guess there was some bad drivers. Also, not only siphoning of fuel was happening, but also the discrepancy, documented discrepancy. Before the implementation of this system, the discrepancy was 10.54%. That means how it was happening. For example, some days the vehicles were off. So in reality, they did not work, they did not perform any operations, they were parked. But by the document, they were filled with diesel, regular amount of diesel, daily amount of diesel, as if they were working. So After the implementation of this system, 6 months later, this discrepancy fell down to 1.95%. But anywhere from 0 to 2, generally that could be a discrepancy, you know, considering how big the tanks are, you know, some spillage could be happening. The next step, fuel siphoned from the fuel. What they did, true story, they would fill up the big truck from the filling station. They would drive off, not even hide from anybody, drive off and then siphon all the fuel to the fuel transporter, and then come back to the same filling station and fill up again. So fuel siphoned from the tanks before the implementation of the system, this is a huge amount, 28,652 liters per month was siphoned from these vehicles, and that's, I'm only talking about 24 vehicles total. So now it's 580, so you can multiply. After the implementation of the system, each driver was signed material responsibility for the vehicle, for the commodity, for the fuel, for the, you know, for the duration of the operation. For example, the driver comes to the shift in the morning and he signs a special paper now that he is responsible for this fuel from 8 to 5, you know, during his work shift. So after the implementation of the system, after some bad drivers were fired, after some others were sanctioned, it's 0 liters. If we put it in money, per month, they used to waste on the fuel thefts and the fuel discrepancies $36,000, and this is for 24 vehicles. If we multiply $36,000, I mean, if we do some simple math, it comes up, let me just bring it this digit here, $8,100, almost $1 million. Quite expensive diesel for Kazakhstan. Yes, it's not cheap, even though Kazakhstan prices are quite low. Okay, so what were the results for you know, for overall of the implementation of the system? Obviously, lower fuel and fleet maintenance cost, right? Also obtaining information about the fleet operation at all fields, anywhere. You know, weekly reports, as we you know, as Maksim told us, how the Galileosky devices work with the transfer of the data. So regardless of absence of GPS and the GSM, we still are able to get this data. One more thing I wanted just to tell here, how, you know, it's new information, but also they are working now on implementing the radio frequency, like infranet system in the mines, you know, because they want to move to the next step. They want to get this monitoring online. So, but they are still working on this one. We don't have the results yet. I mean, whether they are successful and how they will do it. So that's very interesting. Very interesting and very expensive project from the, you know, Kazakhstan integrators for big mining corporation. But as you can count, as you can see, it does pay off. Maksim?
All right, I guess that's it. I guess we can move to the question section, and there is one question which I presume is addressed to me from Mr. Pratik Vogmode. Do you have sheet where your team has tested with different type of vehicle with model number for CAN data and which parameter was captured by Galileosky device? Yeah, it's out of this topic, of today's topic probably, but still, yeah, we have some list of the vehicles which we have decrypted by ourselves or by help of our partners. However, right now this this list is used internally. In case you have certain vehicle which you would like to decrypt or which you would like to check with us whether we have the data or not, please address your request to our support team, support@7gis.ru, their email, and they will check if they have this vehicle or something close to it, which presumably has the same CAN data delivered, and will provide you with the script, the ready-made script and the parameters which are eventually gathered. So this way, right now, we are doing our job in making this list more complete. It takes some time. However, there is a vast amount of vehicles that are already there. I don't know exact numbers, but there are a lot. So, okay, anyway, thank you for the question. Are there any other questions? I believe they are in the chat part of it. All right, anyway, uh, the question from Mr. Prince Robert: what's the percentage error of your fuel sensor? The question to Tim.
The percentage of error is the same basically for all fuel level sensors of capacitive type. The accuracy is 99% of full tank amount. For example, when you have a 400-liter tank and you do the proper calibration of our sensor, you will achieve 99% accuracy out of the full amount of the tank. And this accuracy goes for all capacitive type sensors. I am talking about good quality ones, because obviously there could be some losses during the calculation, during thermocompensation algorithms not being implemented properly. So there are quite a few things that need to be considered. So for all of our competitors and the ones we know, the ones we have big respect for, and for our sensors, the accuracy is the same. It's 99%.
Yeah. All right. So another question from him: why did they prefer using RS-485 to RS-232 sensors? I guess both of us know the answer.
Well, yeah, but historically, we noticed that when we speak about Latin America, when we speak about Asia, the RS-232 is much more preferred by people, right? In Russia and Europe, historically happened that RS-485, we like it better. It has more network addresses. It has more, the possibility of connecting more sensors. And then again, when we try to connect to any other tracker, Galileosky, it's RS-485. So historically happens that RS-485 is the most popular interface, perhaps.
Well, I guess in this case specifically, the most important question was to get the accurate data. So, and you mentioned that the form of the tanks were quite irregular.
Yeah.
So in this case, oftenly we need to use two sensors on one tank and connect it to the single tracker. To the single tracker. At the same time, there are obviously the cases that when there are few tanks, so we can multiply it by 2 once again. So we have 4 sensors which we should deploy and connect it to the single tracker. So, and since RS-485 really gives you the opportunity to build the network of up to 16 sensors in case of Galileosky, I guess this is the only reason why I should do it. Well, there are a lot of questions to you. For example, the question from Nikolai Fialkovsky: what are your advantages over Technoton and Omnicom?
Can you hear me? Okay, yeah, this is classic. I love it. Thing is that we have very deep respect for both companies, Technoton and for Omnicom. Really, they are professionals. They make no bad products. They have very good, very reliable products, right? The problem that we have faced, our company have faced some time ago, as we started with as an integrator, the versatility, right? They needed, the integrators need not expensive, but universal and reliable sensor. Right. For example, when we speak of TD-150, this sensor is made of the glass-filled polyamide. This development comes to us from military. That's what they use in producing the stock butts of the AK-47. All kind of plastics in military are not just plastic, but mostly polyamide. So that's what we use in our sensor. So it is strong. It's not expensive because it's not supposed to be expensive. We have centralized manufacturing. I am above the factory right now. The factory is below me, 2 stories of the factory. So everything is made in one place. place. Everything is made in one spot. So the whole total quality control is happening on one place. Everybody is employed, you know, and just looking over for quality. And I mean, frankly, maybe it's sad, maybe not, but generally the salaries in our region are not compared to one from United States or Canada. So, you know, when we speak about some sensors from other countries, they may be more expensive because economics are like that. Also, why TD-150? Why Escort sensors? They are versatile. For example, TD-150 can transfer data simultaneously by RS-485 and analog. So that's your possibility of connecting a few devices. That's your possibility of connecting to the gauge, to the stock gauge of the vehicle. We have model called TD-600. That model combines RS-485, RS-232, frequency, impulse, and you know, Modbus interfaces, CAN bus interfaces. It's all in one, tilt sensors. And even though we pack the sensors with technology, they are not expensive. You know, we think that modesty in price is crucial, especially nowadays, since for the integrator, the fuel level sensor is only a part of the system. You know, so many spendings you have to do. You have to buy a good tracker, which is not cheap. You have to buy a good monitoring system, which is not cheap. You know, in order to stand out for the integrator, he has to optimize the costs. And then again, he has to avoid going again to the object, you know, 2 years later, and then replace the Chinese sensor, whatever, I didn't say that, but replace low quality sensor at his own cost. So maybe he could save some money at first, or overspend some money at first, and then end up with a need to change the sensor. So again, Technoton, Omnicom, I think we have very interesting developments. Like, for example, we have wireless fuel level sensor, which we used a very special battery for, which we used very special compounds for. Unfortunately, in mines, it's not possible to use Bluetooth because of a lot of radio frequency interference. So that's why they opted out for TD-150. But generally, if you can avoid laying the wires throughout the frame of the vehicle, why not try it? You know, at first, some people were skeptical. I was skeptical too. But 2-3 years later, our sales in India, for example, are 50-50. We sell 50% wired, 50% wireless. So generally, I can say our advantages are versatility, strength of and good quality of the sensors, and modest price, and innovation as well.
All right, 4. Let's make it 4. All right, what's the lifespan for the sensor? The question from Prince Robert.
The lifespan for the sensor is 10 years. Warranty for wired sensor is 5 years, and for wireless is 3 years.
All right. Thank you. Another question in chat, I guess it's for me. Can we get fuel level info from vehicle CAN bus without sensor? It's possible, yeah. There's obviously built-in sensor, which is done by the OEM manufacturer. It's there. It's not that good accuracy, actually, than the capacity fuel level sensors done by Escort or some other companies that having a good quality that presume that it will be 99%. Still, it gives some picture about what is the fuel level there, and it's possible to obtain that parameter. The problem with the CAN bus, as usually, is that different vehicle manufacturers, they decide by themselves on how they will transmit data on CAN, on fuel level into the CAN bus. So in order to get the parameter which is the fuel in CAN bus, you should decrypt it. You should decrypt the data which is coming from CAN. So we have the tools for it. I guess it's another topic, not for today's conversation, definitely, but we have a CAN scanner application that helps our partners to easily find any required parameter in CAN bus, including the fuel level. We have a short video on our YouTube channel on how to get the fuel level through CAN bus. Feel free to enter it and check it. All right. Another question from Mr. Nikolai Fialkovsky. Are there auto calibration method for large tanks, calibration takes a lot of time. Do you have something at your side?
Very true. Calibration does take a lot of time. We recently have introduced the dry calibration feature. That is to avoid setting full and empty levels for the sensor. So that means when you cut the sensor, you don't have to set full and empty. It could be done automatically dry without any fuel. However, tank calibration is necessary. Well, you see, generally it works like this. 10 centimeters of level in the glass equals to 1 amount of liquid, and 10 centimeters of the same level in the pool equals to different amount of fuel. So in a way, we have to teach the sensor what tank it was installed to. We cannot avoid it with this type of technology, with capacitive type. However, we can optimize it. One thing is to ditch the wires, which is possible with Bluetooth sensor. Another one is to use calibration machines, which is also widely used by most integrators. Therefore, make it the process automatic. So while you do the installation of the GPS tracker, you can set the machine to do the calibration for you. Yes, unfortunately, or I mean, it is what it is. You know, you have to do the tank calibration for capacitive type sensors, but do not have to make full and empty calibration anymore.
Yeah. By the way, you thought about machines for calibration, and it might be built based on Galileosky device and EasyLogic. So we can build the script where when we will count the amount of fuel that has been put through the flow meter, check the level at that moment, and check what is the voltage or the signal over S485 to write it down. Make another, add another portion of the fuel, and then we'll make this process automated. So we will open the valve in order to put the fuel down to the tank. To count it, we'll count it through the flow meter. Once we have 10 liters done, we can deactivate the output once again. And so this logic will help a lot. It's possible to build that script. Yeah, you should just use some probably experience. So that's it. All right, next question. Yeah, we have moved to the chat tab, so let's go on here. We have few minutes left. Is the fuel capacity calculation of the sensor, the question from Mr. Ravis Bonders, in case there are two of them, done internally in the box or later on when the data are transferred to the system? I guess this is the question to me, probably, because I have the answer. It might be done in both ways. So yeah, the classic way is that it is done on the platform side. However, in Galileosky we have the technology for calibration and tarring the fuel level sensors right inside of our configurator, so we can do it right inside the box. It is done on filters tab. So if you have a Galileosky device at your premises, get the configurator done, switched on, and check the filters. It's there. The question from Mr. Prince Robert, another one, talking about the wireless sensor. What is the source of the power, since I see no connection to it? Yeah, can you tell about the power source, the battery?
Absolutely, yeah. It is battery powered. It took us a while to find the good battery. You see, the technology that Bluetooth sensors uses is called BLE, which stands for Bluetooth Low Energy. With new battery, I mean, not the new one, but the one we end up using, we've done mathematical calculation on how long it could last. It will last 7 years. We haven't been selling them for 7 years. We only been selling them for 3. But I can say that the first ones we sold that are still operational and still the battery voltage is within the acceptable range. One thing that the battery has to, match what kind of requirement it has to match to. We all been through the situation when you find an old TV remote or some kind of old device that uses lithium ion or alkaline battery, right? And the battery is dead because we haven't been using this device for a long time. So the battery killed itself. It leaked. So the acid is everywhere. So it's not operational anymore. That's not going to happen with our battery because this is a special compound. It's called lithium thionyl chloride compound. It self-preserves itself to avoid self-oxidation. So it generally is designed for the devices that have to work for a long span of time, but use a little energy. So that's what Bluetooth Low Energy does, and that's how the battery operates. In case if you'll have to change it for some reason, maybe after 5 or 7 years, you can do it yourself. You just have to reseal it back with any neutral automotive sealant.
All right, and I see another question regarding the topic from Mr. Muhammad Amin. 7 years, if it's pink every 1 minute during ignition on, right?
Yeah, 7 years. But as I mentioned before, it's a mathematical calculation. So for the fact, from the experience, we'll tell you in 4 years. But yes, the way it works, the sensor is basically in sleep mode all the time. 99% of the time. It wakes up every second and sends the packet of data out, advertised, so the tracker catches it and interprets it. Measuring of the level of the fuel and the temperature of the fuel is happening every 10 seconds. So the sensor, that's what takes the most energy. Every 10 seconds, the sensor measures level of fuel and temperature of fuel and keeps sending that last packet every second into the air. So whatever device would be around to catch it will catch this packet of data and interpret it. There are custom we've done some custom firmware updates for some of the integrators that have been using BLE sensors for a while to do this every 3 seconds to make them last longer, or to do the measurement every second, so the battery will not last as long, but the graph will be more detailed.
All right, thanks. The question from Mr. Ravis Bonders, and he attacks, I guess, the fuel level sensing by addressing to flow meters. So why did you choose to have a fuel sensors, not the flow through sensors? Any downsides from your side? How do you think?
Well, when we speak about this particular company, they did use flow meters. So as I mentioned, their high goal was to achieve absolute accuracy. They wanted to track fuel on every single step. So most guys who would like to get this kind of accuracy, they would install, especially for this kind of heavy, big machinery, they would install flow meters that are made by very famous company out of neighbor country, and they would also use fuel level sensors, because that speaks for itself. Flow meter will give you the consumption of the fuel by the engine, so that the fuel flows through it. The fuel level sensor will give you what is going on in the tank. So in order for you to avoid any tampering of the fuel from, siphoning from the tank, the flow meter will show you an increased consumption, but fuel level sensor will tell you the place and the time and the amount of fuel siphoned from the tank. So generally those are two differences. It's not the same device, but they are similar. They work with fuel, but they complement each other.
Yeah, thank you. Another question from Mr. Nikolai Fialkowski. What if a mix of diesel and biodiesel is used? Will the accuracy drop?
The thing with a fuel level sensor, it has to be calibrated. It has to be calibrated with the same type of fuel it will be used later with. Obviously, you will not fill up diesel truck with gasoline. Right, biodiesel, for example, let's say you did calibration with regular diesel, and then let's say you have a vehicle that eats anything. You can fill it up with a biodiesel and diesel, and it will still work. yes, the accuracy will change. You know why? Because the sensor will measure the ppm, parts per million, feature of the fuel. That's basically how many particles of serum in this fuel. It's way, you know, I have to learn more about this, but this is a deep chemistry. But what I can say that ppm value is different for each kinds of fuel. Sometimes it could be different for, let's say, from one city to another. You know, if I fill up in Kazan and I drive to Moscow, and in Moscow I can get different quality of fuel, the same thing. So yeah, that's happening. The accuracy could drop, not significantly though. So still enough for you to determine theft, underfilling, and things like that.
All right, thank you. Yeah, we have answered the question from Mr. Mohammed Amin. I guess we have time for a couple of questions. Fuel inside the fuel tank during the time fluctuation of fuel and draining. How to protect from it? The question from Mr. Prasenjit Ghosh.
Thank you for the question. Well, there is a setting. It's called filtration. It uses a patented intellectual algorithm. We could use it both ways. It could be intellectual. Basically, we set up the volume of the tank and it filtrates by itself, or it could be manual. So when you know what kind of roads, what kind of machinery you would be using, this way you use the filtration setting. It could be set anywhere from 0 to 15, depending on the harshness of the conditions. And in this particular case, in this Kazakhstan case, they used two sensors, to countercompensate for each other. So that definitely increases the accuracy.
All right, thank you, Tim. Well, okay, let's move to the question tab and get back if we have some time. Finally, the question to me from Mr. Topic George: can Galileosky Wi-Fi work like mesh network topology? It's a good question, though. However, right now, our logic of operation over Wi-Fi is quite straightforward. So we just have two ways and two objects in the Wi-Fi network. It is the client or the hub. So we have the communication between them, and it's only about getting data from the client by the hub, and from the hub of the client delivered to the platform. So it's a quite straightforward logic. However, it's never say that we'll never advance something or develop. So yeah, let's see where the time will bring us to. So I will not call it mesh right now, at least not at this moment. The question from Mike: where is the temperature sensor placed in the fuel sensor? Tim?
It is placed right inside of the sensor head, and it touches the tube. I think it touches the inner tube. So generally speaking, it's not submerged into the fuel, but the tubes that we use are aluminum, so it gives you quite good impression of what the fuel temperature is. However, the main purpose for the temperature sensor is not to give you the temperature of fuel, because it will give you that with a delay, a few minutes, right? But it's mostly for thermal compensation due to the physical ability of bodies to expand and to contract due to the high heat or absence of the heat. You need such kind of thing as a thermal compensation for you to avoid situation when, for example, you fill up the fuel transporter inside of the warm garage or station, and then it drives out in the cold, and then after driving 30 kilometers it brings less fuel by volume, but it's not reality. By weight it's the same fuel, it's just contracted. So that's why the temperature sensor is in there.
All right, great. Thank you. So we've finished with the question stop, and few small questions in the chat, and we will finish for the day. Some drivers are stubborn to an extent of pouring water into the tanks, thus affecting the sensors. Are your sensors affected by such as well? Tim?
Well, yeah, it's we've heard some crazy stories about drivers. It's I could go on, I would never stop. But yes, the sensor will detect the contamination. Well, the water is more heavy than the fuel, so it will go down, right? The sensor goes all the way to the bottom. So once the space between two tubes is filled with water, the sensor sends out automatic 7,000 code. It's a mistake code that is specifically tells you that there is a short circuit of the electrodes of the tubes. It could be short circuited by water, by metal shavings, by some impurities in the tank. So yes, it will send you the 7,000 code, and then you would know that you need to take a look at the tank. Perhaps there's some water on the bottom.
All right, and the last question to me from Mr. President Gosh, can we get engine RPM by using Galileosky tracker? Yes, you can do that, definitely. So we can deliver the data as well. All right, I guess that's it for today. Quite a great webinar, and thank you, Tim, and thank you for everybody who has joined us. It's a great pleasure to see so many questions and so many people interested in the solutions that we mutually perform and produce. So yeah, stay tuned to other activities of ours, and stay tuned to Escort's activities. So I guess they have their webinars as well. So they might be, our mutual webinars might be interesting for you in the future. So Tim, to you.
Thank you very much, Maxim. Thank you very much, guys, for inviting, for giving this opportunity. This is always better to tell about the case with some other hardware manufacturers, because we look from the same perspective, and we know how it is to create something from the scratch and eventually into the product and into the solution. And yes, this is very valuable. We'll try to get some more real life cases for you, because I know digits are very exciting. When you know how much you can save by implementing the monitoring system, you do not care how expensive it is to install the system. Now you can see the data. So thank you very much, guys. Thank you for your time. Thank you for your attention.
Thank you. Stay safe. All right. Bye.
Bye-bye.